Okay, so now that we've figured out what our options are, right, we've thought about how to write down our budget constraint, and we've thought about how to represent our preferences, right, we've thought about what our indifference curves are going to look like, all that's left to do is figure out how to determine what's your optimal choice, which is to say, the option that you can afford, right, that's within your budget constraint, that makes you as well off as possible on the basis of whatever you care about, right, on the basis of your preferences. So to think about this, let's go back to the example we had before, right, where you can earn a wage of $10 an hour, right, you get a non-labor income, right, money from your rich uncle of 60 bucks, right, and so we said that your budget constraint is going to be C plus WL, right, your expenditures have to be less than or equal to your wage times the total amount of time you've got available, right, in this case 24 hours a day, plus your non-labor income, right? Expenditures have to be less than or equal to your income, which in this case is going to be C plus 10L, less than or equal to 240 plus 60. We graph this thing, we've got leisure, 24 hours, consumption, up to 300, right? We said that you can afford 60 units of leisure if you don't work, right? We'll have a budget constraint like this, with the wage equal to 10. Now let's add to this. Let's say that you've got preferences represented by the utility function, U of leisure and consumption is going to be, let's say, 3 times the natural log of L plus the natural log, I'll say 1 times the natural log of C. Right? So we're going to have Cobb-Douglas preferences, which is to say that we're going to have fairly normal looking curvy indifference curves. So as a reminder, how are we going to figure out our optimal choice on a budget constraint given an indifference curve? Well, if we've got a bunch of indifference curves, right, I'll just draw some here. There's really 2 possibilities, right? 2 ways that we can be at our optimal choice. The first way that we can be at our optimal choice, well, actually, I'm going to back up. There's one possibility. Anytime we're at our optimal choice, what that's going to mean is that everything above our indifference curve, right, everything better than a particular point, let's say a point like this or like this, is unaffordable, right? There can't be anything that we could choose that's better than what we do choose if what we do choose is the best thing available, right? So in this case, something like point A, not going to be optimal. Why isn't point A optimal? Because everything above that indifference curve is better than point A, right? In particular, this is better than point A, and this is better than point A. Both of those are affordable to us, right? There's overlap between what's better than point A and what's within our budget constraint. A place like point B, though, could be our optimal choice. And why is point B our optimal choice? Because everything better than B, right, everything above this indifference curve isn't affordable to us, right? It's outside of our budget constraint. So this is the first way that we can have an optimal choice, right? Now in this picture, there's 2 things to notice about point B that are very important, right? Just to remind you. The first thing is that it's on the budget constraint, right? In other words, we're spending all of our resources. There's no way for us to get more leisure and more consumption and be able to afford that choice. Why does that make sense? Because we're going to assume that leisure and consumption are always good, right? We'd always rather have more free time and more money. What else is true is that the slope of the indifference curve here is equal to the slope of the budget constraint, right? So our MRS, the slope of our indifference curve, is equal to the slope of our budget constraint, which is the price ratio, which in this case is just W, right? And these 2 things have to be true of any solution where we could work more or less at the same wage rate, right? In other words, this is going to be true at any interior solution. Why does that have to be the case? That the MRS is equal to the price ratio? Because otherwise the indifference curve would cross our budget constraint, right? If we've got 2 curves that touch at a particular point, The only way that they're not going to cross each other is if they've got the same slope at that point. Okay, wonderful. So that's one possibility is an interior solution. The other possibility is that we choose not to work at all. So if we had a difference curve that looked like this, for example, right? The point where we're on our highest indifference curve, right, we're as happy as we can be, while still being in our budget constraint, is going to be where we're not working, right? It's going to be a corner solution. And in this case, we still have to be on our budget constraint, but it's no longer true that our MRS has to equal our price ratio, right? In this case, as we'll talk about in a minute, what's true is that our MRS has to be greater than our price ratio, right? In other words, the value of our last moment of leisure has to be greater in terms of dollars than the amount of money that we can get. Okay, so given this framework, let's think about what our optimal choice is going to be given this budget constraint, given these preferences. Well, if we decide to work, right, as we just said, we'll have MRS equal to price ratio, and we'll have on budget constraint. So first of all, let's find our MRS. Our MRS, in terms of L and C, equal dF dL. I'm sorry, du dL over du dc. Right? What's du dl? What's the partial derivative of our utility function with respect to L? Well, the derivative of log L is just going to be 1 over L. So this is going to be 3 over L divided by du dc. What's the derivative of log C with respect to C? It's going to be 1 over C, right? So our MRS is going to equal, right, 3 over L divided by 1 over C. I can multiply the top and bottom by 1 over C to get 3 times C over L. Wonderful. So I can set my MRS equal to W, right? Say 3C over L equals W, and therefore conclude that C has to equal W times L over 3, right? In other words, in order for my MRS to equal my price ratio, in order to have an indifference curve that's tangent to my budget constraint, I have to consume consumption in a ratio with leisure given by W over 3. Wonderful. So what do I do next? What I do next is that I plug this into my budget constraint. Right, so my budget constraint is C plus 10L has to equal 300, right? I can plug in that C equals 10 thirds L. So 10 thirds L plus 10L equals 300, right? Because C equals 10 thirds L, right? Which tells me that 40 thirds L equals 300. L is equal to 300 times 3 over 40, which is going to be 225. Right? So now we figured out the amount of leisure, 22.5, my goodness. Right, so now we figured out the amount of leisure that we're going to choose in order to make us as well off as we can be, given our options. All that's left now is figuring out our optimal consumption, which we can do by saying that C equals 10 thirds L, right? L is 10 thirds times 222.5, which is going to equal 75. Great. So we found that our optimal choice here is going to be consume 22 and a half hours of leisure, right? Spend 22 and a half hours playing hacky sack and ultimate frisbee, and then consume $75 worth of stuff every day. Wonderful. One last thing we should do is double check our answer by making sure that this is in fact on our budget constraint. So we can say C plus WL is going to equal 75 plus 10 times 22.5 equals 300, which is of course the value of our total income. So we're good, right? We figured out that our optimal choice is going to be spend 22 and a half hours in leisure, consume $75 worth of stuff. So that's one type of optimal choice, right? That's the way that we're going to find our optimal choice when we decide to work some particular amount, right? When we look for an interior solution. But there's also the possibility that we're going to look at our options and decide that the best thing for us is to choose not to work at all. When we're earning a wage of $10 an hour, we just thought that that's not the case, right? Our best choice is going to be to work a little bit. But let's imagine that we earned a wage less than $10 an hour. How will we figure out the lowest wage at which we're willing to work? So we're going to give this a name, which we'll call our reservation wage. Which is the lowest wage we're willing to work. It's another way of saying that when we're offered a reservation wage, we're just as happy working as not working at all. Now in this case, what it means for us to not work is that we're going to end up here, right? So in this case, not working means, right, that we're going to have L equal to 24, right, 24 hours of leisure, and C equal to 60. So if we want to figure out whether it's going to be worth it to us to work, we should ask the question, is the 24th hour of leisure worth more or less to us than we could get, more or less to us as leisure, as it would be if we converted it into consumption, right, if we decided to work. So how we're going to answer this is by figuring out our marginal rate of substitution at this point, right? So our MRS, L and C, as we found before, right, is going to be given by 3C over L, right? So our MRS of 24 hours of leisure, 60 units of consumption, is going to be 3 times 60 over 24, right? What's 3 times 60 over 24? Well, 60 over 24, well, 6 over 24 is 1/4, right? So this is going to be 30 over 4. It's going to be 15 over 2. It's going to be 7.5. So what this tells us is that very last hour of leisure, or that very last moment of leisure, is worth $7.50 an hour to us, right? So if we're offered a wage of $10 an hour, we're going to want to work, right? Because we can get 10 units of consumption by giving up an hour of leisure. It's only worth $7.50 to us, 7.5 units of consumption. But if we were offered a wage of $7 an hour, we're not going to want to work at all, right? Our last moment of time is worth more to us as money, worth more to us as time than it would be as consumption. Graphically, what this is going to mean is that the slope of our MRS at this point, the slope of our MRS at this point is equal to 7.5. Whether we work or not is going to depend on whether we're offered a wage higher than 7.5, right, like $10 an hour, or if we're offered a wage lower than 7.5, right? If we're offered a wage higher than 7.5, there's going to be some interior solution that's better than staying out of the workforce. If we're offered a wage lower than 7.5, there is no interior solution, right? Every possibility where we work is going to put us on a lower indifference curve than the one where we don't work at all. Okay, great. Now, one last thing I want to say about reservation wages is that the strategy we just used, right, finding our reservation wage by finding our MRS at the reservation, or at the point where we choose not to work at all, is only going to work when we have fairly normal-looking budget constraints. We've got a really weird budget constraint. Like, let's say that there was some amount of commute time that it would take. Or actually, you know what, I'm not going to do that. Let's say that in order to work, right, I had to buy a pair of pants that wasn't sweatpants. And that's going to cost me some money, right? So what that means is, out of that 60 bucks that my uncle generously gives me, in order to work at all, I'd have to give up, let's say, 20 of the 60 bucks, right, buying a nice pair of pants. In this case, my budget constraint would have a weird spike, right? I could get 60 bucks if I stayed home, but if I decided to work for 1 millisecond only, I'd be left with only 40 bucks, right? So in this case, I might decide not to work at all if I had an indifference curve that looked like this, where the slope of my indifference curve is actually less steep than the wage rate, right? If I value my last hour of time at, let's say, $7.50, right, as we said before, and I could make $10 an hour, it might not be worth it for me to work because I'm not going to get $10 for the first hour I work. I'm actually going to lose $10 for the first hour that I work, right? In this case, I'm going to be at my reservation wage. If I'm offered some wage, or my best choice working, right, which is probably going to involve working a significant number of hours, is as good as my best choice not working. So I want to show you this, not because I'm going to ask you to ever calculate reservation wages in these cases. You could do it, but it's a real pain and it doesn't teach you very much. But because I do want you to understand this graphically and conceptually. And I will ask you to think about whether someone in a situation like this is better off working or staying home. Okay, wonderful. Okay, so the last thing I want to do is pull everything we've talked about together and talk about finding labor supply curves. So the basic idea with the labor supply curve, what we're looking for, is to say that at any given wage rate, we want to know how much time you're going to spend working, your labor supply. The way that we're going to do this is we're basically going to say, for any amount of time you spend in leisure, the amount of time you're working is whatever's left over, right? Once we find your optimal leisure, we're going to know your optimal labor. So in order to find our labor supply curve, we're just going to need to figure out our optimal leisure for any given wage. How do we do that? We go through exactly the process that we just did to find our optimal choice of leisure for a specific wage, but for a general wage, right? So if we take our problem before, our general budget constraint, it's going to be C plus WL, right, equals 24W plus 60, right? We'll say that our MRS for leisure and consumption, we calculated as being 3C over L. It's going to have to equal to our price ratio, which is just equal to W, right? Instead of 10, we're just substituting in W. So now we'll say C has to equal W over 3 times L, right? Plug this into our budget constraint, right? This is our optimal ratio that sets our MRS equal to our price ratio. Plug this into our budget constraint, and we'll get C plus WL equals 24W plus 60, right? W over 3 times L equals W times L, or plus W times L equals 24W plus 60, right? 4/3 times WL is going to equal 24W plus 60. So from here, we're going to say that L, which is leisure, right, is going to equal 24W plus 60 over 4/3 times W, right? What's 24W over 4/3 times W? The W's are going to cancel, right? 24 divided by 4 is going to be 8 times, 24 divided by 4 is going to be 6, which times 3 is going to be 18. So I'll say my leisure is going to be 18, and then plus 60 over 4/3 times W, right? 60 over 4 is 15, which times 3 is going to be 45. This is going to be 18 times 45, over W. Right? Now, it turns out, as we found, this is only going to be true when we're above our reservation wage. So actually, our optimal leisure is going to be L equal to 0 if W is less than 750, right? 18 plus 45 over W if W is greater than or equal to 750. Wonderful. So if we graph that, right, we've got W, we've got leisure, we'd say when the wage is below 750, leisure is going to be 24, my goodness, right? When wage is less than 750. We've got a wage less than 750, we're going to spend 24 hours a day in leisure. As our wage increases, right, we're going to spend less and less and less time in leisure. Right? But we're never going to spend less than 18 hours engaged in leisure. So we're going to have an optimal choice of leisure that looks something like this. So given that, what's our optimal labor supply going to be? Well, as we said, right, labor supply is just all the time that we don't spend in leisure. Right? So labor supply is going to equal 24 minus L. So this is going to equal 0 if W is less than 7.5, right? And it's going to equal 24 minus 18 plus 45 over W, right? 24 minus 18 is 6. It'll be 6 minus 45 over W if W is greater than or equal to 7.5, right? So our labor supply picture is just going to be the mirror inverse of our leisure picture, right? At a wage less than 750, we're not going to work at all. We're never going to work more than 6 hours a day, right? Our maximum is going to be 6. And as our wage increases, we'll get closer and closer and closer to working 6 hours a day. Okay, fantastic. Thank you so much for sticking with me. Look forward to talking to you more about this once we meet in person.